Okay. Right, we're live. I think we're live. Okay, interesting. So, hi everyone. Thanks for those who are tuning into the live stream. This is episode one of the Bitcoin Developers Twitch channel. So this channel is going to be predominantly focused on Bitcoin development, how to build Bitcoin wallets, how to integrate Bitcoin and Lightning into different types of applications. Today we have Raj with me, who's going to show us how to use some of the functionality within the BDK, which is the Bitcoin Development Kit. But before we get started, maybe Raj, you want to introduce yourself and tell the people a little bit about how you got into Bitcoin and what you're working on.
Hey, thanks, Matt. Hi, my name is Raj, and I'm from India. And I started on Bitcoin around late 2017. And at first, my interest was mostly on learning this new financial technology that is coming into the world. And slowly, as I started going deeper into the rabbit hole, I also found my childhood interest of learning to code, which got backtracked and kind of sidetracked through my academic discord. And so I started learning code, I started learning Bitcoin stuff, and over time, I kind of uh, fell in love with computers, programming language, and Bitcoin stuff in general. So starting back in July this year, I started working on the BDK project and some other open source Bitcoin related projects surrounding the basic protocol level stuff like pay join implementation, coin join implementations. I try to work and put some review efforts into Bitcoin code also. And as a general, I am just having fun and learning my way through this amazing technology.
Okay, awesome. So some of the people that are watching this might be wondering why I'm speaking to a bunny rabbit with laser eyes. Do you want to talk a little bit about the situation there?
so in Twitter, I was like trying to find a funky avatar, and I already like misjudged and put my boring real name into it. So I thought like maybe like I can do something with my big profile pictures over there, and this picture really spoke to me and like kind of put the essence of like a bunny rabbit looking into this never-ending rabbit hole and like thinking whether to go inside or not. So that's kind of me.
Awesome. And it's an important point actually, because there's a lot of people who contribute in Bitcoin who do so on a pseudonymous basis. Obviously, people can see this is me here, and I've got my video on. But I think it's quite important to hone in that you don't necessarily have to reveal your full identity to be working on the front line of Bitcoin and this new technological innovation that we're seeing take place. So, did you have any thoughts on just that as well?
Yeah, and I actually think like it's actually more important to have more pseudonymous developers inside the ecosystem because developers need to be independent and they have to like be able to put forth their thoughts and like their preferences and opinions without the possibility of having political backlash or like maybe having like some rogue nation states coming after them. So it's an important project and developer needs to be thinking freely and fearlessly, and for that like pseudonymous entity works perfectly, and Bitcoin ecosystem and the developer community works majorly by very long been contributing pseudonymous developers like Z-Man and many others, and yeah, it's always better to have people who are like important for their ideas, not for their identities.
Yeah, totally agree. And so yeah, I've just got your Twitter up on the screen here. So if people want to follow you and find out a bit more about you and your work, is probably Twitter's a good place to start, maybe. Yeah.
Yeah, that's the best place to start. My DMs are open, so anybody wanna chat and have like discussions about Bitcoin stuff, feel free to ping me.
Awesome. So we have this thing called the Bitcoin development kit. What is the Bitcoin development kit?
So Bitcoin Development Kit is basically this wallet project started by Alecos, and this is basically a long-standing industry need to use Bitcoin infrastructure and low-level Bitcoin logic inside lots of wallet codes. Like every wallet needs to have some ways of interfacing with the Bitcoin network, talking with the Bitcoin protocol, and do the Bitcoin stuff. But the problem with Bitcoin is like it's a long learning curve and it takes a lot of time to figure out all the internal details of how Bitcoin works and stuff. So this Bitcoin development kit is basically a wallet library created for wallet developers so they can use the Bitcoin internals and Bitcoin building blocks very quickly and very efficiently to create their own wallet infrastructure. So the idea is that the wallet devs only need to concentrate on the thing that they care about, that's making the wallet logic and making the wallet user experience seamless, and all the boring Bitcoin nitty gritty stuff is taken care by Bitcoin Dev Kit.
Okay, awesome. And if I'm a developer that wants to build mobile applications or desktop applications or things that are running on like embedded hardware devices, is the BDK something that's suited for?
Yep, and the major focus of the team right now is to create a lot of foreign function interface, like it's basically like wrappers into different other language like Kotlin and Swift. So mobile wallet developers and people working on other codes, other language can use the BDK dev kit. The dev kit is written in Rust, but there will be language bindings. I think there are already Swift bindings available and Python bindings available. So Python developers, Swift developers, Android developers can directly use that from their whatever like repositories they're using to get the dependencies from. So they just have to plug in into their dependency as a Bitcoin dev kit, and then they're good to go, and all the functionalities will be available from them for them.
Okay, so there's going to be a lot of support for different languages. And what is the repo for that? I think I came across it the other day, right? It's the BDK FFI repo, right?
Yeah, there is a BDK
So,
FFI repo. So there
mhm.
is BDK Swift. So BDK Swift is basically Swift binding for BDK. BDK FFI is basically the generic foreign language binder for BDK. So we have like iOS, Android, and JVM thing which are in work in progress. Python stuffs are already working. They need few finishing touches from Thunder Biscuit, and yeah, probably by mid of next year, all of the language binding stuff will be available for wallet developers from different language to use.
Okay, amazing. And that, I guess that opens up the door for a whole host of different types of developers, regardless of like you can, I guess, program in the language you're most used to on the platform you're most used to as well, right? So that's
Yeah,
pretty cool.
and that has been like the basic need for stuff. So even if like we have like generic Bitcoin libraries for a specific language, but when people wanted to use like React JS or like Swift or something else, they had to write their own Bitcoin logic from scratch. So this will be very helpful for the ecosystem. This will be very helpful for the industry to build up lots of wallets and lots of different cool products very quickly and very efficiently.
Okay, that sounds really cool. Okay, so I think that's a nice little introduction, and we can kind of dive to straight into what we wanted to do today. Um, so maybe a bit about myself. So I this tutorial is going to contain some Rust code, which I know very little of. Um, I am more of a front end kind of development person, so you're gonna have to definitely walk me walk me through this like quite slowly. But what we're trying to do is we're gonna try and create like a very basic wallet where Bitcoin Core is used as the backend. I should have got my slides up from the talk I did actually. I've got a very basic visual about about that, but basically the BDK supports different types of block sources. So today we're going to use Core as our backend, but you can use an Electrum server, or you can use Explorer, or you can use more privacy preserving ways of getting block data, such as like Neutrino or BIP157. So yeah, I mean, without further ado, should we kind of just jump in and see how we get on? Yeah.
Yeah, let's do it.
Okay, cool. Let's change windows here. So if I share, I guess first thing I want to do is probably get up a terminal and start a new project. So let me just get a terminal up and share that. Okay. Cool. All right. So got my terminal open. Want to start like a new project. I've got a projects folder. I don't know. What do we want to call this? Let's just call it Bitcoin, or we can call it BDK Core RPC demo or something like that. I think that would do for now. And then yeah, let's CD into that. And then cool. So where do I go from here? So I want to. I'm assuming I need to get Bitcoin Core from somewhere.
Yep. So if you don't have already Bitcoin Core installed, so inside that tutorial, it will be also helpful to have the tutorial on the side, because we can like go through step by step, and it has all the necessary links that we will need.
Yeah. So I've got it. That's a good point. Should we have it side by side, or shall I kind of have it up and we can kind of talk through it like while it's in the background? I'm not sure.
That will also work. That will also work.
Yeah. Okay. Let's do it like that and see how we go. If we need to kind of do this split screen thing, we can as well. No issues. Maybe as well, if people want to follow along, we can probably post the link in the chat. I can do that now. Yeah. Cool. All right. So that's in the chat as well. So yeah, so I guess I need to get Core from somewhere if I don't have it. I actually do have it, and I do have the binaries already. So we can kind of skip it. But if anyone wanted to know where to go to get them from, where do we head to?
So there is the Bitcoin Core repository, where all the binaries for the Bitcoin Core is listed depending on version numbers. So the website is bitcoincore.org, and the link is bitcoincore.org/binary/the version.
Bitcoin. I can't spell anymore.
I think the best way to do it.
You broke up a little bit there, right? Right, say that again. You broke up a little bit, my friend.
So the best thing to do will be to go to the tutorial and click on the link.
Okay. So in our tutorial, we've got.
So the prerequisite section discuss like how to build it from source. So this is basically the Unix build documentation inside Bitcoin Core. So if somebody wants to create the binary and cook it inside their own local machine, they can do it also, but it's a little bit time consuming. It takes some time to compile Bitcoin with all the features. So the best thing, the easiest thing for our stream probably is to do is like click on the previous link, not the build from, just go to the tutorial and yeah, Bitcoin Core repo. So if you click there, so this links the repository where all the binaries are listed. So you can see for each version there are different builds. So I'm assuming you are using OSX64. So this OSX64 thing will work for you. Yeah. So if you download this thing, it will download a tar file. And if you extract that tar file, you will get the binaries. And you just have to put the binaries in your path, and that's it. Your Bitcoin Core is installed.
Okay, that seems pretty straightforward. And I have done that already actually. So, if I swap over again to my terminal and see if I can get it running. So, let's swap over here again to the terminal. What do I do to check if I'm running? So Bitcoin Core comes with a CLI already, doesn't it? So I could
Yep.
guess I could try and see if the CLI is up and running already by typing maybe make the terminal a bit bigger actually. Yeah, Bitcoin CLI help. Okay, so I get this
Uh,
error message that says could not connect to the server 127.0.0.1 port 8332, and I'm assuming that's because the server's not running, the daemon's not running, right?
Yep. And another clue that it's giving is basically the server is set to mainnet. So the port number is 8332. So once you start the server, it will basically start syncing with the mainnet. It will basically go to the initial block download phase. So
And
if
that's
we
what we
want to
don't want.
skip that thing, we don't want that. If we want to skip that thing, so what we have to do, we first have to create a Bitcoin conf, a configuration file for Bitcoin. So you will be having in your home directory a .bitcoin folder. Can you check that?
My home directory.
Yes.
So um, actually,
If you
I
just
think,
write CD, it will go to home directory. Yeah, just CD.
and then like that,
I,
right?
I, I don't think anything else is needed.
Oh, okay. So just CD.
Just CD and enter.
Yeah,
I think that's your home. And can you do a ls hyphen la?
yeah. So I
So
can't
you
remember
should
actually where I
have.
put core actually. I think it's in I think it might be in
It's
my projects
probably.
folder. So let me just
Hmm.
I
But
think
the
it's actually
default Bitcoin daemon. Hmm.
I see. Because I've got core 22 here. Uh so if I ls here, but these are just like the binaries and stuff, right?
These
Not
are the
the actual.
binaries. Yeah.
Mm,
I think you have to
mm,
create that. So let's create that. That will be a good way to show like how to start Bitcoin from rec test.
okay. So we need to create
So
a bitcoin.conf
we need to
file.
create a directory named .bitcoin, and inside that directory we need to create a text file called bitcoin.conf.
Ah, okay. So in the home directory, is that fine?
Yeah,
So
inside the home directory itself. Yeah.
okay. So we want a directory called bitcoin
.bitcoin.
dot bitcoin. Yeah. And in there we want to, so if we cd into there, and we want to create a file called bitcoin.conf, is that correct?
Yes.
Yeah, okay. What's creating a file? Can I use Nano to do that?
Yeah, you can use Nano.
Yeah.
Yeah.
Yeah. And then bitcoin.conf. Okay, so this opens up a Nano shell for me.
Right. And inside that, we need to put some configuration option that will
Okay.
tell how our Bitcoin D will be configured. So if you go back again to the tutorial, I have a sample configuration option over there.
Okay, awesome. So I can just do a copy and paste job like that, yeah?
Yeah. Yeah. So the configuration basically says like we want to create a rectest node that says rectest equals to 1. This is
Mm-hmm.
a fallback C parameter that the rectest node needs. The server equals to 1 means whenever we run Bitcoin D, we don't want to see all the Bitcoin daemon logs. The Bitcoin daemon will run as a backend server, right?
I see.
The
Yeah.
transaction index tells like we want to create transaction indexing inside our core. So without that, certain RPC functionalities doesn't work. And
Mm-hmm.
the RPC user and RPC password are basically the RPC credentials with which we can access the Bitcoin Core RPC port. So the RPC port, whenever we are trying to send some request, will ask for a credential and we have to put this user and password inside it. So
I
now we
see.
can just save this file.
Okay. We don't need to set the port from which requests are coming into, do we? Is there like a default port that's already
We
established?
can set the port because if we don't want to use the default port number, but
Okay.
for our purpose, the default port will work. There are other,
Okay.
so what there are many other configurations option in Bitcoin Core, and
Okay.
like whatever configurations we don't set, they will be set into their default value.
I see. Okay, that makes sense. So let's save this. Cool.
Right.
Um,
So our .bitcoin folder is set. We can go back to our home directory
mhm.
and we can start Bitcoin D.
Okay, so literally just type Bitcoin D, yeah?
Yeah, literally just type Bitcoin D.
Okay, it's doing some things. It's doing a lot of stuff.
Yep, and it says like all the things, and in initialization has been done, and
Hmm.
all the things are setting up properly. And because it's a rec test, it will not try to connect to other peers in the network and do the normal Bitcoin core stuff. It's basically our toy Bitcoin node that we can like use to play around and create our own blocks and stuff.
Okay, so this is all just like locally. So just for the people listening, there's different networks that developers can play around with, right? So we
Yep.
have like the main net, we have the test net. We're going to be operating in reg test mode. What are the like differences between some of those? I think you cut off a little bit there, Raj. You, you still with us? But bear with us. I think there's a few Wi-Fi issues. Okay, yeah, someone's in the chat just saying that is correct. Mainnet, testnet, regnet. So yeah, I mean, if you want to just have like a play around and get up and running quickly, like you can basically create your own local version of the blockchain because syncing to mainnet is quite costly and expensive. Can take up to a day even. So for our purposes, we just want to get coding straight away. So we kind of this kind of setup makes sense for us. Um, okay, Raj is
Yep.
okay.
So
Raj is back. Raj is back. Okay, good.
yeah, yeah, so we don't want to like test us on mainnet, right, with real monies because things can go wrong. We want to like be wrong and like see failures and stuff. So for that, we use rec test where we can create our own blocks. We can create our own weird kind of transactions.
Hmm. Okay, that makes sense. Um, cool. So we have Bitcoin essentially running in the background in reg test mode now.
Yes,
Uh,
right.
what do we where do we go from here?
So we want to test our Bitcoin CLI at this moment, see if everything is working. So
Okay.
you can like make a command Bitcoin CLI help and see what the output is.
Okay, I can probably close this window because it's kind of making me dizzy. So I'm gonna close it. Um, actually, no, that I can't close it, can I? Because it has to it has to stay running. So I'll just open that, and that's why I opened another. Oh no, it's already. So okay, so once it runs, like to stop it, I'm assuming there's a command to stop. There's like a Bitcoin the stop command or something, right?
Yeah, so
Yeah.
but there is a Bitcoin CLI stop command, not Bitcoin D
Bitcoin.
stop, Bitcoin
Oh,
CLI
okay.
CLI
That
stop.
makes sense. Okay, so we want to check what is going on. So let's check with the CLI and see help. So getting all of these CLI commands, interesting stuff. So you've got stuff around. Scroll to the top here, and it's sectioned off by different, I guess, modules. Maybe is the right word. I'm not sure, but like we have some commands related to just like blockchain stuff. So if you want to get
Yeah,
blockchain info and the latest chain tip, what the difficulty is. Okay, some stuff around the mempool. Okay, interesting. Is there any commands we want to try out here, or this was just basically to make sure we're up and running? I think you might be going in and out a little bit, Raj, but we can hopefully you arrive back in a second. But yeah, I think ultimately like the CLI is it's actually quite a nice way to learn about Bitcoin as well, because like I was saying, like it's sectioned off such that you can do all of the commands as it relates to like your wallet, for example. So creating wallets and backing up your wallet, getting or generating new addresses, different types of addresses, legacy addresses, and the newer style of addresses such as Betch32. What other kind of stuff do we have here? I'm just keeping a little eye on the chat as well. What we've got going on in the chat. The GitHub repo is great for learning Bitcoin from the command line by typing simple commands. Yeah, totally agree with that. That's how I kind of learned some of the more in-depth stuff about Bitcoin, like the CLI. You don't need to even know to program either. Like you can literally just like download the CLI, download core, download the CLI, just start playing around and typing commands. So okay, let's see if we can get Raj back now. Okay, cool.
Hey Connor, can you hear me?
Yeah, welcome back, my friend.
Yeah,
Right?
yeah, I'm back.
Okay, awesome.
Wi-Fi stuff. Yep.
Yeah, no worries.
So yeah, so what we have here is basically a long list of RPC commands, right? So these are basically commands that we can issue to Bitcoin Core, and Bitcoin Core will reply back with the answers for those commands.
Sure, got you.
Right. So there are few wallet-related commands that we'll use, but we will. So inside this tutorial, we have this setup of like we will have one wallet with BDK and another wallet inside Bitcoin Core handled with Bitcoin CLI. Right. So these two wallets will send funds to and from to each other, and we can use the wallet using Bitcoin CLI and issuing the commands to Bitcoin Core, but we will do another like fun part of doing it, and we will do that programmatically. Like without doing Bitcoin CLI, we will issue these RPC commands from inside our Rust code.
Okay, that makes a lot of sense. So just as an example, if you wanted to run something from the CLI, there's get mining info, which probably won't return anything like okay. So and this returns like the amount of blocks in our blockchain, the difficulty, and the chain, which is saying main, which is
I think it's running main chain.
Yeah, is that because yeah, that's interesting. Is that because I've not do I actually have to pass it like a reg test flag or something? If anyone in the
I don't think we need to
comment as well.
I don't think we need to do that because we have already set the conf file. If we didn't set the conf file, we have to put that. Can you do one thing, like can you stop the node, say Bitcoin CLI stop?
Okay.
Okay, and
okay. So Bitcoin. Sorry, say that again. You broke up a little bit.
Yeah, do ls-la from home directory.
ls-la, right?
Yeah. And there should be a .bitcoin folder. Yeah, there is. So can you go inside the .bitcoin folder and see what's the content over there?
Yeah.
I think we did something bad with our bitcoinconf setup, and for that it didn't work.
Possibly didn't we? Let's see.
It's there. So something is wrong. So this thing is not being registered. So somewhere else is the Bitcoin data directory. Can you do one thing? Can you close this? Close this folder and start Bitcoin again, Bitcoin D again, but only see the first part of the logs. There it will tell about the data directory it's using.
Okay, so hold on. We've got a comment. I think you may need to specify the location of the conf file if you're not using the default location.
So I thought the default location is the home directory. So that's why like the creating the .bitcoin folder in the home directory should work.
I feel like you're right though. But if I do let me just double check this quickly. So if I do that,
It's actually not using that folder as its default
yeah,
directory,
it's not.
because if it did, then there will be other folders that it would have created. So it's probably using something else. And the way to check that will be, can you start Bitcoin D again and like see the first few portion of the log?
Okay, let's see.
Yeah, just scroll up. Okay. So here, like you see the config file. There in the log using data directory. Okay, so it
Oh no. If I
so
do
it's
this,
using some other default data directory. You can press Control C and it will stop.
yeah. So I've stopped it now, but I can't scroll all the way up now. Maybe let's
Okay.
try it. Let's try it again. I think
Just start it for a little while and stop. Yeah.
Okay. So
Yeah.
okay, so we're in library application support. Application support.
Okay. So can we just directly nano inside that bitcoin.conf file using that path, that config file path?
So this one basically, right? Let's see.
No, not that one,
No.
because that's not the full path. Just use the full path. Otherwise, you
Okay.
have to use the tilde in front of it.
Yeah, of course. Okay. So
No, that's
no.
Bitcoin wallet.
Okay. Okay, here we go.
Yeah, this one.
Okay. Okay, so it's empty.
It's using the library application. That's not a full path of the file. The file was application something else after that.
Yeah, it was, wasn't it? Let's double check that again. So no, it was actually. I didn't know
It
where
was
are we?
application support.
Bitcoin and then .bitcoinconf. It says it was found. Not. Oh no, it says
Okay,
not
okay.
found. It
There is
says not.
another easier way to do this is like when you are running Bitcoin D, we can use the data directory configuration flags and to point it like we don't want to use the default data directory, whatever it is. We want to use the .bitcoin.conf file.
Okay, one comment here. Let me see if this can help us out a bit. So the Mac OS, I think, uses this different location than Linux. It's using. Okay, maybe I tried that. So one second. So I think if I just put the tilde before library, let's see. Maybe this will work. No, no, I need to
tilde
do.
slash. Put a
Yeah,
tilde
tilde
slash.
slash. Yeah.
No, it's still going at application, but we need application support Bitcoin, then bitcoincom. So
Oh, I see. I see what you're saying. So library, then application, and then support. So like that. That doesn't
yeah,
seem right. Hold
probably.
on. No, I don't think that's right. So using data directory, library, it says like config file not found. So it's searching in that directory, but it's not. It's
Yeah,
saying not
because we
found.
haven't created a config file over there, right? So it looked for a default config file in the default location. It saw that there was no config file, so it created its own.
Okay, so we might need. Just reading some more comments. Because
Yeah,
of the space.
we have to write it like this: application slash support.
Okay. Application slash support. I'm seeing backslash, or I think it
Backslash.
does.
Yeah.
Yeah, I don't think it matters, does it? Let's see.
No, that's not also a file because it's saying application/support.
So I'm really revealing my lack of terminal skills here, but let's see. Let's keep going.
So do this thing. Before
Okay.
before support, put a space. Just before support, put a space.
Mm-hmm.
Delete that slash and put a black slash in front instead. After
Okay.
application, put a backslash. No
Mm-hmm.
space after application. Yeah. Delete the space and put a
Yeah.
space in front of support.
Give that a go, yeah.
Yeah. Now see what happens. It's a empty conf file. I'm not sure like whether it should be
So
an
what if
empty
we?
conf file.
Yeah, I'm not sure either. Maybe if I
So
put
let's
the
try another
config.
thing. Let's try another thing. We can put
Just
data
before we do,
directory flag over there.
okay, shall I try and put the config that we had originally, the contents of that in here, and see if that works?
I'm not sure if it will work. Let's put something like this.
Okay, yeah,
I have
we've got
sent
a
you a
little.
text.
Oh, okay.
If we can run Bitcoin D like this, like
Okay,
let's see what happens.
let's give that a go. No, I need to get rid of this. Okay, so what
Also
we're
the
doing here,
tilde at the
so
back. Also the tilde
yeah,
at the back.
oh yeah. Okay, so what we're doing here, so we're trying to run the daemon again, but we're creating a data directory at the root in the Bitcoin folder. Okay.
We are basically saying that daemon to like use Bitcoin data directory, which is from our home to .bitcoin folder. Don't use. We are saying just don't use the default directory. Use our folder as the data directory. But it's saying like specified data directory does not exist.
I don't feel good. Let's see. I need to do an LSLA. Okay, that's a bit confusing because I see it here, right? You can do data directory. Okay, we've got some more comments. They have the right path now. Just the bitcoinconf file there is empty. Okay, yeah. So I just, I think, so I just copied the contents from what was in the original conf to the right path. I think now. So let's try run it again and just see, just to double check that that is the case. 1 second.
So in the conf file, we have this bitcoin.conf. Oh, another thing we can do is like, can you like go to that location with your file browser instead of like terminal?
Okay. Let's try that.
That will be, I think, easier to navigate.
Yeah. So we want to basically go here, but from the actual. I think I can do it. Okay. bitcoinconf does not exist. If I do that. All right, what is in here? Okay, so this is a bit of an easier view, I guess. So
it's not shared.
Okay, so it's not here, is it? So I guess we just have to try and create one now, right? If I do, oh, I'm so used to not creating files in the Finder now. Let's see. And I just rename this. So it needs to be bitcoin.com. Okay. So now, so now we should be able to go back to the terminal, nano into this, and then change the contents of this, right?
Should be able to do that, yep.
Okay, let's give that a go again. Support bitcoin.com, and then we nano in. Right, we've got all this rubbish now because I copied the file, but cut text is Command K. How do I delete all the content? In fact, what I'll do is instead of doing it in Nano, because Nano is a bit annoying, I'll just do it in VS Code instead. So let's open up a code editor and just do it there. And VS Code is shouting at me. I don't know what this means. Trust authors of all files and fine, I guess. I don't know. Okay, so we want to copy what we originally had, reg test one. Oh, I forgot people can't actually see this, can they? Let me share my other window. This is my terminal. Okay, this is my code editor. Sorry, yeah. So yeah, because I've forgotten the Nano command, so I just opened it up in VS Code instead.
And this is also the correct folder, and because I can see the other files and folders inside that should be inside the Bitcoin data directory. So I think we have pasted it in the right place.
Okay, all right. So it looks like we can try this again.
Yeah.
So as you can see, like
let's try Bitcoin D.
Yeah, running core is a little bit tricky at times, but let's give it another go. So, okay. Oh no, I just want to run, don't I? I just want to run it now.
Yep.
Yeah. Okay. Yeah. So we've got config file, reg test, RPC password is blank server one. Okay.
I think it passed it properly. RPC user password server TX index are also set. Now just try Bitcoin CLI, get block info, get blockchain info or something like that, or get mining info.
Yeah, let me just split my terminal. So yeah, so if I do Bitcoin CLI get mining info. Yeah, that's what I expected to see. Yeah, okay, and chain is registered. Okay,
right,
cool.
So you can see how the blocks is 0. So we basically don't have any blocks right now inside Rectest. So that's how Rectest starts. So we have to create our own blocks when you have to go.
I see. Okay. Do we need to do that now, or is that further?
No, we can skip that, and that will be done inside our demo itself. So we don't have to do that manually.
Okay, cool. All right. So I guess now we can. Let me just look at the time. Okay, cool. We've got plenty of time. I guess now I can jump into the project folder and we can start doing some things.
Yep. Finally, we got Bitcoin working.
Yeah. Thanks for your patience, people watching. Me showing my lack of terminal skills there. But so what did I call it? I called it BDK Core RPC demo, and then I think I can just open a code editor at this point, change my screen again. Probably should just share my whole screen, but Windows seems to like work a bit nicer, I think. So okay, so I've got an empty project folder. Basically, for this I'll just use the integrated terminal in VS Code. It's just a bit easier. What do I do? How do I start using BDK?
So the first start after we have our Bitcoin thing done. So we have the setting up phase, right? So we need to create our new cargo project. So the command is cargo new, whatever the project name is.
Okay, cool. So we can do cargo. So what's cargo? Cargo is like a package manager type of thing? Or?
Yes. So cargo is the package manager for Rust, and it's used for a lot of different things, including like downloading dependency package and stuff. So when we say cargo new and some name, so it will basically create a Rust project with some template files inside it. So we can start editing from that template file. We don't have to create our scratch.
Okay, so I got this. That happened almost instantly. Okay, so if I go inside it, okay, so I've got these files now.
Yes. So inside
Source.
the source directory, your source code will be there. So it by default creates a demo main function for us that just basically prints hello world. And another interesting thing to check is the cargo TOML file.
Okay.
So inside the cargo TOML, we specify our dependencies, basically what other libraries that we want to use in our project, right?
Right.
So once we have this cargo project done, then the next thing to do is like try to run it. So if we try to run the main file, that should just print hello world to our terminals right now. So if we just say cargo run, that's project file name.
So cargo run and then the project
I don't,
file name.
yeah, but we don't need to put the project file name. Just say cargo
I can
run.
just do
Yeah.
cargo run. So I think I'm in the wrong directory here. Hold on, CD into. I think I want to do that, right, and then cargo run, and we should get some like hello world thing, right? Cool.
Yep. So our cargo
Just
file
just
is
just to
working.
go back, a little sec, just in case there's anyone who doesn't like have cargo or Rust installed. I think you can get it from Rust Up, is it? Leave a comment in the chat if you know the link for that. And that's the Rust toolchain installer, I believe.
Yeah, so
And this,
if you just search in Google, like
yeah.
install Rust in terminal, there will be a single line code that you can like copy paste and that will do the whole thing for you.
Oh yeah, so something like this, yeah.
Yeah, this guy. Yep.
Okay. Oh, okay, that's cool. And that comes pre-packaged with cargo as well, yeah.
Yep.
Okay, that's very cool. All right, let's switch back to the code editor to VS Code again. All right, so we're happy. We've got Rust installed, we've got cargo installed, and we've managed to run the program that comes kind of like I guess the boilerplate that comes with
Yeah. The
it.
cargo default.
Yeah, the cargo default. Okay, cool. Where are we going from here?
Okay, so in the tutorial, after setting up and all the things are working, now we need to set up our dependencies, right? So we will need only two dependencies for this tutorial. The major dependency will be BDK, and then we will use another small crate called dirs next. That will be used to find out our home directory because we want to put our wallet data inside there.
Okay.
So if you go to the tutorial and setting dependencies section, so
Yeah. Okay, so I've copied something in here, just straight from the
yeah,
tutorial. I think I've got
yeah,
my lines set at to break at 100 characters, but it's fine anyway. So I guess the syntax. So yeah, talk me through the syntax a little bit. So this is where you would set dependencies. I think if you're from like maybe the JavaScript world or the npm mod, you have like package.json, which is similar thing and lists out your dependencies. So I'm assuming this is quite similar. It looks like we're
uh,
describing what version we want to use and some of
yeah.
the
So we are specifying like we want to use any version equal to or above 0.10, and there are certain default features inside the BDK library, but we don't want to use that. So we have said like default features equals to false, and we have specified what are the specific features that we want to use. So we want to use the all keys feature, we want to use the key value DB feature, and we want to use the RPC feature. So what all keys does, it allows us to have BDK to create the different kind of keychains, right? And the key value DB says that BDK has the capability of having a persistent database storage. And the RPC says like the BDK will have a Bitcoin backend, which is the RPC backend. So
right.
BDK comes with already like pre-installed default backends, for example, Electrum, Explorer, Compact Filters, and RPC. So for our purpose, we will use the RPC backend. And if you see the three features, this basically nicely summarizes the three key components that a wallet needs. So the wallet needs some ways to manage the keychain. So all the private keys and public keys, it has to store somehow and access them somehow. That is done by the all keys thing. Then it has to store those keychain data and other block data into some storage. That is done by the key value DB. And then it has need some access to talk to the Bitcoin network or the Bitcoin interface, the blockchain interface. So that is done by the RPC.
Okay, very cool. Okay, cool. So we don't need to like do a cargo run again to
No.
pull those in dependencies in again. It's kind of like we can just start using
Yeah.
we can just start using them, yeah.
Yeah.
Okay.
So we have like we told like Cargo that we will be using BDK and does next as our dependencies. So from there we can like start using the component of these libraries inside our main function. So
Okay.
once this is done, we will go to main function and we will like import certain elements inside our program from this BDK and this next libraries. So for that,
Okay.
we can again go back to the tutorial, and I have specified the list of dependencies that we need to use. There are many other things apart from these ingredients, but for our purpose of this tutorial, we'll be using only those things. So just
Okay.
simply copy pasting those dependencies will be enough.
Yeah. Okay. I'll write one out by hand just for my own kind of thing. So
Yeah,
this is saying so it has the use keyword, which I'm assuming is it's a keyword. So
yeah. It's
and
kind of the
then
same as Python's from something
yeah,
import
or like
this.
yeah, exactly, or JavaScript import or whatever. So yeah, so and then we can it looks like you use the name of the package or library, and then
Yeah.
you can
We need to put colon twice.
it's twice.
It's
Okay,
kind of like the C++ namespace thing.
I see. Okay. Um.
So yeah, so BDK also exposes this Bitcoin library. So Bitcoin
Mhm.
library is basically the Rust Bitcoin library, and from there we get all the building blocks for Bitcoin, like address, amount,
Okay.
block headers,
So
and
like
all these kind of stuff.
here are like all your modules almost like yeah. Okay, interesting. And like there's one called network. I'm assuming. Yeah. Okay. Cool.
Yeah.
All right. That's
So
cool.
network is a module. I think you have to put it in a small name, the small letter case of network.
Uh, okay, your tutorial's got it as uppercase, so I'm
Oh,
assuming that.
oh, okay. So yeah. But my mistake. Network is an enum, not a module. So yeah, we can
Okay,
get that enum.
okay, cool. So I will copy the rest, just so I don't bore people with typing out dependencies, but or modules. And why am I getting this ugly? Oh, it's because it's unused. Okay, okay. VS Code is shouting at me. That's kind of
Yeah.
horrible.
So
I wish I. That's
yeah,
one thing about code editors that annoys me. It's like you input something and then it's like all these squiggly lines everywhere, and it's like, have you done nothing wrong? No, you just not used it. It's like, all right, but cheers.
yeah.
Um, okay, so there's some other stuff going on. So like for example, here we have this util bit32, and then we have the syntax open colon derivation
Yes.
path and key source. So they're like
So this
exposed
syntax
modules within
basically
that.
means
Or
like if we want to like import multiple stuff from a single module. So for example, line 3 says like from Bitcoin's utility module, there is another module called BIP32, and inside BIP32 there are many things, but we want to use the derivation path and key source from it.
I
So
see.
whenever we want to use multiple items from the dependency module, we use the second bracket thing.
Okay, got you. Makes sense. What else do we have going on here? Anything else that's interesting? Yeah, so this is just exposing like a whole host of modules and some functions within those modules and stuff. So okay, that seems pretty straightforward. Cool.
Yeah,
So we've got all of the stuff we need to get going.
yeah.
Where are we going from here?
So the next thing we need to do in order to use the BDK wallet is we need to create descriptor streams, right? Because BDK is a descriptor-based wallet, and in order to initialize a wallet, we need a descriptor string. So you might have like a descriptor string from other source. You can get one from Bitcoin Core. You can write one by hand, but in this tutorial, we have shown a way how you can use the BDK library itself in order to generate a fresh private key or a descriptor string. So just a little bit background about the descriptor string. So the descriptor string is a very compact way of encoding the key information or the address information, like what will be the private keys and the corresponding public keys, and what will be the format of the script pub keys of the resultant addresses. So this is a very compact way of encoding that, and it comes in a form of a string. And if we supply that string to BDK, the BDK will know how to use that string to create a new wallet with all the private key and the public key and the address type information. Right.
Okay, I'm just I remember there's a documentation page on descriptors on the website. I just wanted to show that very quickly. Okay, so this is the kind of thing you're talking about when you say where are we? Okay, so this is the kind of
Yeah.
thing you mean when we're defining like these descriptor strings, and they look very much like just regular kind of functions that you'd use when you're just programming normally, but they have these
Mhm.
acronyms. What do these
Yes.
acronyms mean? Like PKH and
So
WSH and
So the acronym in front of the string basically means the type of the addresses. So like there are different kind of Bitcoin address. Like there are P2SH address, there are SegWit address, there are
Mhm.
legacy pub key address. So this PKH basically says a pub key hash. So this is a P2PKH address. So this descriptor basically says whatever is the data inside the bracket, take that data
Mhm.
as a private key and create a pay to public key hash type of script using that private key, right? And
Awesome.
then there is WSH. WSH is P2WSH or the SegWit script. So it basically says like whatever is the data inside, use that data to create a SegWit version 0 script pub key. So whatever
Got
the
you.
wallet use for their scripts and like addresses, it will be derived from this descriptor.
Got you. And before descriptors, you would have had to basically write out your policy using script, which is like a lot more verbose and just a bit more difficult to reason about. Is that correct to say? Is that fair to say?
Yeah, true. For example, if you see the third example, this says about a multi-signature address in a SegWit version 0 form. So in just after WSH, there is multi. So multi says like inside whatever inside that multi function, use those things as the argument for creating the multi-sig script and use that script as a SegWit version 0 script pub key. So every
Right.
script pub key will have a hash of a script. The script is called the redeem script that will be there while you are spending that transaction inside
Mhm.
the input data, and the output, the script pub key that the input is spending will have this hash of that script thing. So the entire script is basically described by this descriptor, which is a 2 of 2 multisig, I think. Uh,
Mhm. Yeah.
yeah, probably
Yeah.
it's a 2 of 2 multisig,
Mhm.
and we put the hash of that 2 of 2 multisig inside a SegWit version 0 script pub key, and we
Mhm.
use that script pub key to create our addresses and stuff.
Awesome. Okay, cool. So let's head back. Let's head back into the code editor again. Where are we? Where are we? I think we're here. Yeah. Yeah. Cool. All right. Cool. So we need to uh, we need to generate like a fresh descriptor string to use for our wallet, right?
Yep.
Yeah.
So
So we have a
this is,
nice
I
little
think,
function here.
also where a part like it gets a little bit rocky with lots of
Mm,
codes and internal stuff inside,
yeah.
because this is because the way the BDK wallet, the library has been created, it allows you to use a lot of flexibility in form of
Hmm.
Rust trait things, so people can have their own dedicated structure as their descriptor also. They don't have to use our default descriptor stuff. They can use that, but they can also have their own custom made structures that they can implement the trait on top of, and then they can use that as their descriptor thing.
I
So
see. Okay.
inside our, like, for our purpose, we will
Yeah.
use the BIP39 module of BDK library that comes as like the BIP39 implementation of it, and we
Okay.
can use those BIP39 mnemonics and turn them into our descriptors that we need. So I'm not sure, like, do you want to write this part of the code one by one just to get a feel of it, or you want to copy paste and then we can go through how the steps are going up?
Yeah, because I'm lazy and because we already have it, I've copy and pasted it already. So, but let's
Right.
let's walk through it and
So
see what's
yeah,
going on.
so I also try to comment out over each section so we get a sense of what's happening on each of these paras. So first we need to create a ACCP 256K1 context. So that sets out the elliptic curve parameters, right? All the cryptographic numbers and magical things that we need in order to create our cryptographic calculations. So this is called as an ACCP context. So
So,
for most of our stuff in our wallet, we will need an ACCP context, and the first line is basically creating a new default ACCP context.
okay.
So we have the ACCP context done.
Mm-hmm.
We can give a password to our mnemonic generation process also.
Mm-hmm. Mm-hmm.
So we have set our password to a random password. So this comes in handy like when you are trying to reclaim a wallet with a given set of mnemonic strings, right? So this is like the BIP39 password or the passphrase that you can add on top of the mnemonic. So
Sure.
whenever you are like restoring the wallet from the mnemonic state, you also
Mm-hmm.
have to provide this password. So you set the password over there, and
Mm-hmm.
then you try to create a mnemonic out of this, the third line. So we say mnemonic. So mnemonic comes as a dependency, as like a dependency object from our BDK library, right?
Mm-hmm.
So
So
we
here.
yeah, we took the mnemonic from BDK and we said like generate a mnemonic of 12 words in
Mm-hmm.
language English with SegWit version 0 script context. So
Interesting.
that part over there, SegWit version 0 says like we want to create a SegWit version 0 type of script pub keys, right? So
Got you.
the way to generate that in BDK is like put that type definition inside before like calling the function. So BDK will know what type of object to create. Or sorry, Rust will know what type of object to create. So this is a Rust thing, and yeah. So
Okay.
this is the context comes from the miniscript library, right? So
So
the
are you just
miniscript library.
importing just the type? Oh, it's the enum. Okay, so you're just importing the enum at this point. Okay.
Yes, yeah, it's basically an enum. If you look into the details, it's basically an empty enum that has certain traits implemented on top of it. So it's just an empty enum,
Interesting.
and then it implements the script context trait for SegWit version 0. So this is where all the juicy stuffs are.
Okay, so this is yeah. I'm just racking from my own brain. It's quite similar to Go. So you can define an enum, implement script context for that enum, and then just define a set of, I guess, just functions, right? That do
Yes,
certain
the script
things.
context is basically a definition, or it's called a trait. So a trait
Uh,
is basically a collection of pure functions that you can implement on top of any object.
I see. Okay, so cool. Um, and I see language English. Does it support other languages as well, or is it just? I
Yes,
know the
yes,
most common one we see is like English mnemonics, 12 or
yeah.
20.
I think
So I'm assuming this mnemonic type supports like
language. I
24
think
as
you
well.
can see like how many languages are there.
Okay.
Yes, there are like 15, 18, and these are the variations of the word list that we can have. And inside the language, you can see
I'm assuming like we have all kinds of languages. Okay.
if you
Okay.
go to the definition of language, you can see the list of all the available language there. So there is English, Chinese, French, Italian, Japanese, Korean, and Spanish.
Oh, interesting. Okay. And they're just defined as enums as well. Okay, cool. That's quite cool. Right. So we don't need to go too much into like Rust syntax and stuff. But yeah, we're doing this. What's unwrap? Returns a contained OK value.
So
Okay.
another thing in Rust is like whenever we call a function, the function can return a result. So instead of like directly giving an error out of the function can return a result, and the result can have two type of values. It can have a OK value inside the actual value that is being returned, or an error value. So whenever we are saying unwrap over a function, we are saying like whatever the result, unwrap it and give up the value. If the value is error, then the code will panic at this stage and say like, oh, we got an error we didn't expect at this point.
I see. Okay, that makes sense. Okay, cool. And then now it looks like we're turning our mnemonic into a private key.
Yes, and then we are putting that private key into with that password and making into an extended key, and then we are
Because
using that
we're creating a deterministic wallet here, right? But
yes.
yeah, okay, cool.
So, so this will be a HD deterministic wallet. So
Yeah.
at the last of that step, we have XPRV. The XPRV is basically our private key that we had, right?
Yeah.
So this is the master private key, and we have to derive all other addresses and private public key pair from this master private key. So the to derive from a private key, we need derivation paths. So we will be using like this kind of like standard derivation path M84H 1H0H0. So the M signifies the master key, and from master key we will go to the 84th index. From that we will go to the first index. From that we'll go to the 0th index, and from that we'll go to the 0 index, and that will take as our private key. So this part of this thing is probably, I think, don't remember, but I think this is defined in BIP 84, where it says certain. I remember. So BIP 84 is for like the SegWit derivation, right? So the SegWit addresses are derived from this 84 index path. There are like 48 index paths also, and you can have like any number of index path of your choice. So this is like the standard path we use, and using those derivation paths from that private key, we derived all our other key data, right? So this has been done for the next of the steps. So we are just simply looping over the two items. The first key is 0 index, and the second key is 1 index. We will use the key derived from the 0 index as our external key, and key derived from the 1 index as our internal key. And the internal key is used to create the change derivation. So whenever you are paying someone in Bitcoin, you have a change and you want to get the change back into a certain address, the wallet will use the internal key for your change address derivation.
Got you. Okay, I'm with you. All right. So this returns the key as a tuple. Is that going to return us a string? And I guess we can find out by just running this function, right?
Yes. So inside the main function, we can just run this code and see what it finds.
Okay, so I'm going to type this out just to be busy. But so we get, what do we get? We get a receive descriptor and a change descriptor. And we want to set that equal to whatever our descriptor returns.
We have to put a semicolon at the end. Yes, and then we can print these two things and see what it returns.
Okay, so let's see, how do you do print lines in Rust? So you do something like that, and then just a string. So we can do receive is the first one, and you have to what are these things called when you do these kind of
so this is so these are the like the position where the variables are placed, right?
Okay, got you. And then we want our output to be spaced, I guess, and so the first one will be our receive address. The second one will be our change. We want to output it in exactly the same way. So colon. and then we can pass
This
in like the
colon
two
hash
variables.
question thing is basically like we are saying, put the print in the debug configuration. So the debug configuration is basically like whatever is like the default debug printing setup for that object, it will like
Yeah,
print it out for that.
got you. Okay, cool. And then so it looks like we can just run this now, right? So if I do cargo run, I think.
So now it will take some time to compile all the dependencies because this is doing it for the first time, right? So we haven't run it after like adding the dependencies. So
Yeah,
this
I
happens
got
for
you.
the first time. For the next time, it will not recompile the same thing.
Okay, got you. Got you. Okay, this is exciting. We should get something coming up soon. Okay, it's just getting our dependency still. What's going on in the comments? Anything interesting going on in the comments? How you guys finding this? Okay, 4 days in the building. What's going on, my friends? Got with the fire emoji. Appreciate it, man. Hope you're well. What else? Someone said, anyone know if this is being recorded to be posted somewhere later for those of us working right now? Yeah, so I think this is our first one, so bear with us. But I'm hoping this is gonna be saved, and then we're also gonna upload it to YouTube as well. So okay, I see it.
Oh, nice. We actually got the output.
Yeah. Okay. All right. So here we go. Okay. So we've got this witness public key hash descriptor now,
Yes.
where you're gonna have to
This is
remind
the
me what
key
the
fingerprint. So this is the
yes,
key fingerprint. The M thing, remember inside the descriptor string we were talking about, the M that
yeah,
it starts with. So that's
yeah.
the fingerprint of the master key. So
Ah,
this value is the fingerprint of the master key. This identifies the master key, and then you see the derivation part 84-1-0-0.
oh, that's too small. Yeah, got you, got you, got you, got you. Okay, and then
Yes.
the
Then
change.
the app. Then the actual the after that the TPRV string is basically the private key data.
Yeah, got you, got you. Okay, so
So we have the
I need to. What do I need to do with these now? I need to like. Do I need to
so
save this somewhere, right? Or well, I guess it's already
no,
kind of
we
stored.
don't need to.
Yeah,
We have it inside the code
yeah.
already.
Okay,
So we will just
okay,
use this value whenever we are generating our BDK wallet.
okay. Got ya, got ya. Okay, cool. So we got our descriptors. That went quite well.
Yep.
Cool. All right. So we have some descriptors in which to like instantiate a wallet, basically.
Yep.
Um, where do we go now?
So we have the descriptor helper function done. So this was
Yeah,
the ugly part of the code, and other
yeah.
part with the rest of the thing I think will be very fun to see.
So
So what we do now,
just quickly. So did you say earlier that there's like because I know we've just like kind of written the descriptor by hand, but is there already like is there like multiple ways people might generate their own descriptors? Is this just like one way we've chosen to do it for the
yeah,
purposes of
yeah,
the tutorial? But yeah.
this is like the way to have like descriptor derivation with the BDK wallet, but that's not
Hmm.
the only way to create your descriptor. If you can create a private key string, if you know the private key, your master public key, and if you have the BIP39 implementation somewhere, you can create the descriptor string in your own way. So you just need to have the descriptor string from somewhere in order to instantiate a BDK wallet with it. You can do
Got you.
it with BDK. You can have your own recipe to create your own descriptor string.
Got you. Got you. Okay, that sounds good. All right, cool. So we've got a descriptor now.
Okay,
Where are we heading?
so the next thing to do is like we have our Bitcoin course started already, right? So
We do.
we will now try to talk with Bitcoin Core first before we like jump into the BDK wallet stuff because we
Hmm.
need to make sure like we can talk to Bitcoin Core. Okay.
Hmm.
So in the tutorial, you can go to the talking to Bitcoin core section programmatically, where I have given a little bit description over like how to do that. But
Okay. So
given all these things,
this seems pretty straightforward. So we have to. So we're gonna talk to the Bitcoin Core reg test node that we have running over RPC, but in order to do that, we need to provide some credentials. In our config file, we set the admin, we set the username and password to just be admin and password respectively, just because we're testing out locally. So we use this. What is this? This RPC auth.
So this is the RPC auth that we have also imported from our previous dependencies. So this is like the RPC authentication structure. So with this authentication structure, we can start our RPC client. With that client, we will talk to our Bitcoin Core. So our client will ask for some authentication thing, and this is how we provide our authentication to the client. So in the tutorial, the next line is basically creating the core RPC client.
Sure.
So we are saying client new, this is our port address, and then we are saying we will be using a wallet that named test with this client. So every RPC client will have a wallet, can have a wallet associated with it. So whenever we are specifying wallet related RPC, it will use that particular wallet to get that wallet related RPC answers, because every different wallet will have different kind of answers depending on their data, right? So some wallet might have like different balance. So when you are saying get balance, if you don't specify a wallet, the RPC will ask like, I don't know what wallet to ask for to the balance to fetch from. So give me a wallet name. So this is our way of saying.
I see the path as well is wallet and test. So wallet and then test is the name of the wallet.
Yes, the test will be the name of that wallet.
We didn't define or create a new wallet via the CLI or anything. Do we need to do that before, or does it automatically create one for us?
We will do that inside the code itself.
Ah, cool. Okay, cool. And then, okay, so I guess if we want to see this client print something maybe just to the console, similar to what we did with the CLI, we can use the get blockchain info function, which I'm assuming is just like the same as the RPC call on the CLI, but just in code, basically. Yeah, it's exactly the same, right? So, okay, let's see what that looks like.
Yep, we can
Oh, I think you cut off a bit there, but that seemed to have worked because we got some. Raj, you there? Is Raj still with us? So that returns. Okay, you're with us. Yeah. Okay, cool. So yeah, that returned some stuff. That returned what chain we're on, the blocks, headers, difficulty, all kinds of stuff. So that seemed to work quite well.
Yeah. So our core RPC client is set, and we can talk to the Bitcoin Core through our Rust code. So that's pretty cool.
Yeah, that's pretty cool. Ooh, okay, cool. Right. So that returns some stuff. Cool. What's happening next?
Okay. So now that we know that we can talk to our core client, so now we tell our core client to create a wallet, create some blocks, get some coins, and do the balance. So this is where the get some balance in core wallet section describes. So here you can just copy the code, and it's very straightforward.
Yeah. So this is pretty straightforward. So we'll just copy and walk through it. So yeah, I'm assuming like it says on the tin, really, we're using the core RPC to create a new wallet, and I'm assuming this first parameter is the name of the wallet, and then we've got four others that are.
There are different areas options that we can give, but we are saying like setting them all to none.
Okay, so the options are disable private keys, blank passphrase. Of word we use. Okay. Passphrase. So these are like is that initial, because when we created our descriptors, right, you can optionally provide a passphrase, and that's what you would use to pass in here. Yeah.
Yes. So while creating a core wallet, the core also asks for like if we want to use a passphrase for BIP39 passphrase derivation.
Yeah.
So if we
And
want to use a passphrase, we can use
disable
that.
private keys. What's that about? Disable, and that's a true.
By disabling private key, we basically say like we are creating a watch only wallet. We can only
Ah,
get the addresses of the wallet. We can check the balance, but we cannot sign transaction with it.
I got you. And then blank. What is blank?
I'm not exactly sure what
Okay.
is blank. I have to
Okay,
check.
so blank is a boolean or something. Okay, interesting. And then avoid reuse is I'm guessing it's just avoid address reuse. So don't use the
Mhm,
same address.
mhm.
Cool. All right. Cool. And then we get an
We
address.
get an
Okay.
address. Yes,
Yeah.
we are saying like Bitcoin Core give us a new address. So we
Sure.
want to get some coins inside that address because we want to spend it later, right? So we
Sure.
got the core address. Then we are saying Bitcoin Core generates certain some number of blocks for us. So
Yeah.
so there is a Coinbase maturity number, right?
Got you.
After
Coinbase. I think
100 blocks have been elapsed.
just say that last bit again. I
Can you
think
hear
you
me?
cut off. I think you cut off in that last bit. I think you were just saying that the Coinbase maturity length
Yes.
is
So,
100 blocks. Did you say?
yeah, so a Coinbase transaction is the first transaction that goes inside a block, right?
Mm-hmm.
That's the transaction that the miner gets their reward from, but they cannot spend from that transaction until 100 blocks have already occurred after that block containing the Coinbase. So the miner has to wait for 100 blocks before they can touch their reward, right? So
Got
that's
you.
also true for RPC. So that's why we are generating 101 blocks, because at the 101th block we will be able to spend our first Coinbase transaction,
Got you. Got you.
right? So
Okay.
we are saying code to generate two address, so it will create blocks and it will use the core address as its minor fee generating address, like the Coinbase address, right?
And
So
I'm
we
assuming the core address is just Betch32 by default, yeah?
That depends
Mm.
on like how our wallet is set up in
Ah,
core. I think it will be base
ah,
32 by default. We can
ah.
quickly make a print line and check it, like how the address looks like.
Okay, we
So
can
what we
let's
can do
do it.
is like inside print line, we have like core balance. We can put another variable over there,
Yeah, so what
say
do we
core address.
core address, yeah. And then what do we do? We want that, some parentheses, colon, hash, question mark, and then I guess we just want to print the core address.
Yes.
Running out of lines here. Okay, strange. Okay. So yeah, and then this last bit is just showing the balance, which should be 0, right? Because we don't have
No,
any.
we should be getting 50 in the balance, because we
Uh,
have generated 101 blocks. So the first reward of the first block is activated right now.
oh,
So
okay, of course, yeah, okay, got ya. Okay, let's do that again. Okay, so we print in the block info again. Okay, yeah, so core balance amount 50, which is just it's just the Coinbase fee,
yeah,
value basically. The
yeah,
Coinbase
yeah,
transactions over 101 blocks, and
yes,
then core address, which gives us a
yeah.
bet
It's a
32
SegWit
address by
address.
default. Yeah, segwit address. Yeah. Okay, awesome. Cool.
So okay, so we now have some balance in our core wallet. So I
Hmm.
now we are set to start our BTK wallet stuff. So once
Okay.
we have some balance in our Bitcoin core, we will use this balance later to send some amount of coin to our BTK wallet. But first, we need to create our BTK wallet, right?
Hmm.
So
Hmm.
okay, so okay, next thing what we will do is like in the next section we have the set up the BTK wallet section, and there are certain configurations that we have to set. It's also very straightforward.
Okay, I'm just going to leave a little comment here, but just so I can differentiate between the two. Okay, cool.
I think
So,
it will be also helpful, like if you can comment out all the core thing that we have done, because we will be issuing the same comment like create wallet, get new address thing, generate to address, another 101. Again, if we run the code, we don't want that because we have already done it and the balance is
got you.
already there. We don't want to screw it up.
Got you. So now we're flipping from using the core to the BDK wallet. Okay, so
Yes.
we can stop using.
Not
Yeah.
from there, because the client can stay. That will not cause any
Oh,
problem.
just printing.
From
Okay,
create
just the print.
no
Uh,
from the from create the test wallet to all those commands that we have issued to Bitcoin Core, we don't want to do that again because we have already done that.
oh, of course, I get you. I got you. So we can comment those out. And do we, because this was printing quite a large bit of information, should we comment
Yeah,
that out as well?
we can
Yeah.
comment that out also, and we can also comment out the first print of receive and change descriptor thing if we don't want to
Oh,
have
yeah.
that again.
Yeah. Okay, that makes sense. Okay, cool.
Okay, right. So
This is gonna error as
then it
well.
will
So
go
yeah.
complain and say like we don't know the balance.
Yeah.
Um, okay. So yeah, that thing is done, and
Mhm. So we
okay.
want to. Is it same? Is it a similar thing here? So is it a similar thing happening here? So when we create a BDK wallet, we have to do a similar thing by passing in descriptors with receive and
Yes,
change descriptors.
yes. We have to
Okay, so
set
it's very
some
similar.
database path. We have to set a blockchain backend. We have to set a descriptors thing. The three main components: the descriptor, the database, and the blockchain. So
Okay,
we
so
set three.
okay, so the first thing is the descriptors, is very similar to what we did with the core wallet anyway. So your
Function we are getting
wallet,
the receive and change descriptor.
yeah, and then so the parameters here are, yeah, you pass in a descriptor, you pass in a change descriptor, you define what network you want to use, and then you pass in this sec p
So
context.
this is a special function that we have in BDK that says like we can generate a unique wallet name given a unique descriptor. So if we change the descriptor, the name of the wallet will change. It's basically a concatenation of the checksum of the descriptor. So we wanted some way to have descriptor specific wallet name inside Bitcoin code, because
Ah,
our wallet correspondingly have a wallet at its end. So we want to give it a unique name, and for that we have this helper function called wallet name from descriptor. So given a receive and change descriptor, it will
mhm,
give us a unique wallet name basically.
got you. Just looking at the chat, just very quickly. I got a question. Can we do this in Python or JavaScript rather than Rust? So there are language bindings for Python. I'm pretty sure I saw that in the Discord the other day. I don't know if anyone's around and that's in the live chat and knows. Yeah, we're working on Python now. You see, yeah. Um, so that's in the works. Haven't learned Rust yet. Neither have I. I'm literally learning it now, so don't feel too bad. Okay, cool. Rust seems quite nice though. It seems not too bad. It seems quite,
Yeah, it's friendly, right? It gives
yeah,
nice error messages and all. Sometimes it's a little bit messy with all
yeah.
the borrow checker stuff, but after that it's like quite friendly.
Okay, cool. Let me speed up a little bit because we are over time a little. Well, not we're not really over time. We
Yeah.
can stream for as long as we want, but I did want to try and keep it fairly compact. But okay, let's keep going.
Okay. So we have the wallet name, we have the receive and change descriptor. Now we need the data directory where we store all the wallet related stuff, right? So
Um,
here the did next dependency comes. So the did next can fetch our home directory for us. We could have
uh,
specified home directory like by the text also, but we
mhm,
didn't wanted to do that because everybody might have like different home directory, and I didn't wanted to hard code it into the tutorial. So the did
mhm,
next is like a very nice way to fetch your home directory, whatever it is. So what
mhm,
we do is like we find out the home directory, and then we add like you add a subdirectory called .bdk example. So inside our home directory, just like we had the .bitcoin folder, we will have a .bdk example folder, and inside that folder, all the wallet related stuff that BDK need will be stored, right?
Got you. Got
So
you.
we got the data directory. Now we got the database. So the database is a sled database. So sled is basically a very simple persistent key value database, and we say like use this data directory to open our sled database, right? So sled open with the data directory creates the database, and we need to create a database tree. So database.open tree with the wallet name will create the specific database for that particular wallet name. Now the wallet name is the name that we have derived from the descriptor with the wallet name from descriptor function,
Got you.
right? So
So just so we're saving this to disk essentially, and uh, are we using the default database that comes with BDK here, or are we? Is that what we're doing here? And if so, is it something that can be swapped out to use your own database?
yes, so everything in in BDK is basically trait implementation. So traits are like pure functions. So if you have your own custom database, you can implement the BDK database trait on top of it, and that will be a BDK compatible database. Same with the blockchain thing. So every blockchain has a blockchain trait. So if you have your own custom blockchain implementation that has some weird ways of talking to the Bitcoin network, you just implement the BDK's blockchain trait on top of your blockchain structure, and that becomes BDK compatible blockchain.
Got you. And is
So
this
the
also
sled is
the
something.
kind of, sorry to cut you off, is this the kind of place as well where if we wanted to save it to and using another mechanism like to a cloud service or to some remote server, could we do that kind of
Yep.
stuff here as well?
Yep, we can do that kind of stuff as well. I'm not sure about the cloud thing because that might need some other kind of requirement and setup. What you can do is like we can have a simple JSON file storage thing, right? And implement the database stuff on top of that JSON file storage structure, and that will be a BDK compatible JSON file storage.
Got you. Got you. Okay, awesome. So that's saving some things to some folder somewhere. Cool. And then we need to authenticate again with so here we're setting the username and password similar to what we did earlier with when we was passing in our credentials for the core instance we have running.
Yes. But this time we are creating the authentication for BDK to use the core RPC. So before we were directly using the core RPC, now BDK will also use the core RPC and it will have its wallet inside core also. And then that two wallet will talk to each other and send transaction to each other. So this one is for BDK.
Got you. And then it just automatically runs on at this IP address and this port. Yeah, cool. Got you. Okay.
Yes. Just note that we don't put the wallet path with the name thing over here because that is done automatically by BDK while it's setting up the RPC configuration. So on the top.
How does it know the wallet? How does it know? Well, I guess it doesn't need to know about the wallet, the test wallet that we had defined earlier, right? Because they're basically separate at this point.
Yes. So it will use the wallet name named wallet inside it. So it will create its own wallet called wallet name that we have defined just few lines above, like wallet name from descriptor.
Wallet name. Oh, I see. And the default name it uses is wallet. Okay, I get you.
Yes. So.
Okay.
No, the default name I think is also the default name is wallet, but we will use our own name that we have created because we can.
Yeah, got you. Okay.
Okay, so we have done the authentication, RPC URL, all these things. Now we can create the RPC configuration that we need to pass into BDK. So that thing I think is done next.
Yeah.
Yes. So we create the RPC configuration structure.
Mm-hmm.
So this RPC configuration is basically the configuration of our Bitcoin core daemon, the URL, the authentication, the network, the wallet name, and there is an optional parameter called skip block. Skip blocks basically says like whenever the BDK wallet tries to sync with the Bitcoin core RPC, it
Yeah,
will skip this many number of blocks before like putting stuff into its database.
got you.
So
Okay,
all
I
these
understand.
configurations we
Okay,
are putting skip block is none. We are putting network as red test. We are giving the RPC URL and we are providing the wallet name. So
so just
given this
quickly on the wallet name,
configuration,
I don't think so. The wallet name is not actually, we're not defining it as in like we're not giving a string. It's just like the result of this descriptor. This
yes,
descriptor gives us back
yes,
a.
we could have given like a random string also. It doesn't matter.
I see. Got you. Got you. Okay. Cool. Okay. So then we can probably copy
Yes.
the
So
rest of this and just go through it line by line. But okay. So we've created this RPC config, um, and now we
we are
are what
creating
we
our
do.
blockchain.
Okay.
So we are creating our RPC blockchain backend from this config. So RPC blockchain structure has this function called from config constructor. So
Mm-hmm.
from config, we just pass in the config, it will read the config, it will connect with the Bitcoin core client, and it will create the wallet name, wallet file and all the stuff that it needs to do. And it will create this blockchain thing, the blockchain
Right. Got
backend.
you. Got you. Got you. Got you. Got you. This makes sense. And this basically, yeah, so this is where, or this might be where, like, you choose to. So RPC blockchain from config, can that takes an RPC config. So, but I'm assuming RPC blockchain has other,
Yes,
uh,
there is this RPC config structure definition. So RPC blockchain takes in an RPC config. If you go a little bit lower, you will see the function definition of the constructor. So these are the auth thing that we have created.
yeah,
So these are the RPC blockchain, its own implementation, the functions that it can
okay,
we
I
can we
see.
can call on it.
I've
So we
got
can
you.
get the synced height of the node, right? We can
Yeah.
get the certain capabilities. And if you go a little bit lower at the end of the at the end of the file, there is this from config. Just a little bit above, little bit above, little bit above.
Something like
Here,
here.
here,
Uh,
right? So
Returns a block RPC blockchain backend, creating an
any
RPC client.
blockchain
Okay.
structure.
Yeah. Okay. Got you. Got you. So what? Let's not go into that. I was gonna say, what does the interface look like for like Electrum or Explorer? That, but that's another stream. That's another stream. Okay. Cool. So and then yeah. So we combine everything to finally create the BDK wallet structure. So
Yes.
we create.
So
This is
you can
basically
see
where we
like
actually create the wallet. Okay.
the wallet basically needs the three major things: the
Hmm.
descriptors, the database, and the blockchain. So we have created the descriptors, we have created the database, and we have created the blockchain. We just provide this to the wallet, and boom, the wallet starts.
Awesome. And then we've got wallet sync. So we need to do a sync before.
Yes. So the sync will basically think of it as a scan of the blockchain database. So the
Right.
blockchain has like a lot of data, historical data and stuff, and the wallet
Yeah.
is just spinning up right now. It doesn't know about anything about the world. So the wallet needs to sync with the blockchain to know that whether all the relevant data that it cares about are in the blockchain or not, whether it has a transaction for its descriptor, whether it
Mhm.
has balances and stuff. So the initial sync thing is basically the sync function. So it basically like queries the blockchain and it says like give me a list of all the transactions that I care about, and it passes through those transactions and fill up its database correspondingly.
Got you. Okay. Got
So
you.
another thing like kind of like important to notice, like in BDK the sync function is basically kind of manual. So the user, whenever they are coding their wallet thing, So whenever they say like there is a certain kind of update is expected, or the balance needs to change, or new transaction are coming, they need to call the sync function over and over again until there is no more update that is there. So the sync logic has to managed by the wallet developers. The reason it's done in that way, because that gives them much more flexibility and freedom, like how they want to call the sync, whether they want to call it like very frequently, or whether they want to call it like in a very shallow way, they are reducing their bandwidth and stuff.
I see. So it's not something you necessarily have to do on start of, like, you open,
Yes.
I don't know, you have your mobile on your phone and you open and you do a sync there, and then you,
Yes.
because of, I don't know, certain network conditions might not be favorable, you might decide to do it at the point of going to send some money. That might be a more optimal time, or in the background while the user's doing some other thing, I guess. So okay, there's a bit of flexibility of when you can do that.
Yeah.
Okay, that makes sense.
Okay. So we
cool.
have synced the wallet. After that, we are basically saying like, give us a new address. Like whatever the wallet that has been created, the wallet will give us a new address, right?
Sure.
So, and we are just printing that address. So if we get up to this part, I think we will be good to, we have covered, I think, most of it. The remaining
basically.
things are just the transactions.
Yeah, basically. Okay, so let's do another run, which should output a BDK address this time.
Yeah.
Let's see. So we're running. There's a bit of suspense here. While that's running, I can quickly pop into the chat and see what's going on here. Okay, there's some. Yeah, we did get our BDK address. Let me just quickly go through the comments. People asking about Python, not learned Rust. JavaScript will be a bit harder to do, but BDK does work in WASM, so that might be a better approach for JS apps. Yeah, we need to get BDK running and LDK eventually in the browser. That's in the works. You can compile BDK with the Rust compiler into a WASM target. There is an example here. I won't switch windows, but the link is basically on bitcoindevkit.org, where there's a playground where you can basically use the BDK CLI as well. Another nice way to learn about the library. Cool. So let's okay. So we got our. This is going.
So this is also another SegWit address that our wallet has generated. So our wallet synced with our Bitcoin core backend. It has created its own wallet with that descriptor name, and it has given us a new address.
Wonderful. Okay. So I guess now we just need to try and send some sats around, right? Just kind of.
Yep. So we also need to like go up and uncomment some core client stuff that we have commented. So what we don't want to create the wallet because we have already created it. We have the core address and we have already put the balance over there. So core already has the balance. We have the core RPC client that is there, and yeah, I think we are good to go. We don't need to like uncomment any of this thing because yeah, these will be redundant. So we have the core wallet and we have the BTK wallet. Now we just have to throw some transactions around. So that will be fun. So this part is described is like sending sats around in the tutorial. So
so let's maybe I can bring the. So let me leave a comment here just to say send in. Oh god, can't type. Send in some sats around. Okay. Oh, we need our core address actually, don't we? I think we will need that. Okay, so let's see. Where am I? Okay, so send in some sats around. So what are we? What are we? We're sending from our core wallet to the BDK wallet.
Yes, because we just created our BDK wallet. It doesn't have any balance. All our balances are inside the core wallet. So we will get an address from the BDK wallet, and we will tell code to send some sats to this address.
Got you. Got you.
So the first line is doing that, getting an address from wallet address. We have already done that previously, so we can even.
So hold on a sec. So this is getting a wallet from the BDK wallet, right? Yeah. So this is getting a wallet from our BDK,
Yes.
an address from our BDK wallet. Sorry.
Yes.
And then we're using the core RPC to send to address, passing in an address, giving it an amount, 10 BTC in this case, and defining
And
none
putting
as
all
the
the
rest.
other options as none.
Yeah, so
So
this is okay. This is where you can just be a bit more granular, I guess, with transactions. You can add a comment to subtract fee, confirmation target. Okay, interesting.
mhm.
Cool. And
So
then
I just want to like quickly mention another thing for new listeners.
sure.
There is a very cool website that you can go to whenever you want to like go into the details of all these like core RPC commands and what the different arguments and options mean with their description. So the website is like Bitcoin BTC and
Let's
if you
quickly
go over there,
yeah, let me quickly I can try and get it up very quickly. Where is my browser? Which one do I want? I think I want this one. Yeah, so what is it called? Bitcoin RPC Explorer, did you say?
yes,
Bitcoin RPC.
let me just quickly send you the link. I
Okay.
think that will be easier.
Okay. Sounds good. How are we doing in the chat? You're still hanging in there with us, yeah? Well, I think we'll be done in literally on that in the next 10 minutes or so. So if you're still with us, appreciate it. Hope you're learning a lot. If you have any questions, we might have a bit of time at the end, maybe 5 or so minutes at the end, just to take some questions if there is anyone with some extra questions. Okay, so this is bitcoinexplorer.org. Yeah, I'm sharing my browser.
Okay, so this is basically an Bitcoin block explorer, but what the cool thing about it is if you go to the tools in the drop down,
Yeah.
and there is like RPC browser at the
yeah.
at the list below. Yeah. So you get the list of all the RPC commands, right? So if you click on any of the command, just click on one of it.
Yeah.
And there is a help content.
Yeah.
So this gives the description of all the variable names and the results and their meaning. Right.
Okay, so this
if
is
you
similar.
want to,
So similar to like using a CLI, like help command, or like
it's
passing
basically
in the.
it's basically like passing in the Bitcoin CLI help command. So if you like type in Bitcoin CLI help with a particular RPC command, you will give this information. But this is just a nice graphical way of browsing through all of it.
Got you. Yeah, I didn't even know about this website. This is cool.
You can even execute command over it, and it will give you results. This will be like live result from a mainnet node.
Oh, this is cool. This is very cool. Okay. So if people want to know about like the capabilities of the CLIs, this is a pretty good place.
Yeah, it's actually very fun to like play around with a live mainnet node without like having to go through a lot of trouble of running your own node and going through the CLI and to see how the results are coming. You can see like live data how the things are. So that's very nice and handy tools for new learners.
Okay, awesome. All right, let me head back to my editor again. Where are we at? I think we're here. Okay.
Yep.
I think great tutorial, guys. Oh, thank you. Appreciate it. This is the first one, so trying our best. Hopefully, this is the first of many. We're coming to an end soon, so we're nearly there anyway. So, what did we last do? So we last said we were going to send to the address we had generated by BDK for the
Yes.
amount of 10 BTC, and there are some other parameters that you can use to have a bit more fine-grained control over the transaction. But it seems like, in a nutshell, it's kind of like you.
Mhm.
So you need to generate address. You need to. Where does like the signing and the broadcasting come in? That, I guess that's coming in next, right? So.
No, the core already has a signing
Okay.
wallet, right? So it
Ah,
signs the transaction and broadcasts to the network.
oh, so that's already part of this send to address.
Yes, yes.
Got
There
you.
is another RPC called create raw transaction that will just create the
Got you,
transaction and not sign it. When you
got
say
you,
send to address, that does all of it.
got you. Awesome. Okay. And in most cases, like, well, I guess it depends what you're doing, right? But in many cases, you probably don't need as much control, right? You can just use the send to address out of the box, and
Yep,
it
yep.
will it subtract, not subtract, will it provide a transaction fee that is uh what's the word I'm looking for? A transaction fee that is like competitive for that time that you're trying to send a transaction, or can you like? Just, I kind of know the answer, but can you kind of like get your fee estimation, customize the fee estimation aspect of the transaction?
Yes, yes. So there, but if you see the last two options, the confirmation target and the estimate mode,
Yeah.
these are the two parameters that control how much the fee should be. So
Okay.
if you
Got you.
give a very small confirmation target, it will try to put a very high fee. If you put a very low confirmation target, it will try to put a very low fee. So
Got
the
you.
Bitcoin core internally has the fee estimator thing, and it will do its internal stuff to estimate the fee from the running network.
Got you. Okay, cool. Well, I think my headphones are about to turn off, so we better rush. Okay, so confirm transaction by generating some blocks. Okay, of course, because like when we send, like it needs to be confirmed by like the miners, I guess. Well, not in this case, but we're gonna do the mining ourselves, I guess.
Yes.
Um,
So we need to confirm the transaction. The transaction is broadcasted in the network and
mhm,
it's basically waiting in the mempool. So we need to generate another block so the transaction goes inside the block and gets confirmed, right? So
yeah,
in reg test, we mine our own blocks, right? So the command to mine our own block is like generate to address. So we
right,
use again the core address, and this time we generate just one block because we just have one transaction waiting in our mempool.
got
So
you.
with one block, that transaction will get confirmed. And after that, we will tell our BTK wallet to sync with the core node. Because now if it tries to sync, it will see that it has an address that has a balance in it with a confirmed transaction, right? So
Right.
after the wallet syncs, then it will see its updated balance. Without syncing the wallet only just knows the previous state of the Bitcoin database, the
Got
Bitcoin
you.
blockchain database. Until and unless we call sync, it will not get the updated view. So
Got you.
every time we are expecting some update in the wallet, we are calling sync.
Got you. Okay, that makes sense to me. Um, okay. Let me just think. Is there anything else we would want to do here? So okay, yeah. So okay, so we're syncing our wallet, and then okay. So,
So
this is
then,
this is what I was referring to earlier. Yeah, about creating a transaction kind of thing. So we're gonna go
yes,
into that now quickly. Okay, cool.
yeah. So the next
So
part is how to create our own transaction with BTK.
mm, yeah. Okay, so and we have this transaction builder thing.
Yes.
Okay,
So,
so
but
we
the transaction builder is basically like you can think of it as a constructor, right? So,
okay,
whenever you are trying to construct a transaction, there are various parts that you want to manage accordingly. Like there are like the time logs, then there are the script pub keys, then there
yeah,
are like various input things that you want to set, right? So when we say wallet build transaction, it will give us basically a transaction builder, right? Using that builder and calling various functions on top of builder, we will basically populate the transaction template. with
Got you.
the data that we need. So the basic thing that we need is basically a sending address and the amount. That's the basic transaction stuff. But just like in core RPC, send to address command, like there are a lot of different options about fee estimation, about whether to subtract the fee from the input or not. So all these can be set in the transaction builder also. But for this tutorial purpose, we'll just simply use the recipients and the amount, right? So
And this amount is in this
SAT.
isn't it's in sats. Yeah, I was gonna say that's not a possible amount. Actually, what is that? I don't even know what that number is. Like 5 billion million.
It's basically 5 BTC, something like 5
Yeah, is that 5?
billion or something. I don't know.
Okay. Anyway, okay, and then so I see finalize this transaction and extract PSBT. So BDK uses PSBTs to do
Yes.
transaction, like even if it's a only sending to a single address, or no, so even if it's
Mm-hmm.
only even if it only requires a single signature, it
Yep.
will always use PSBTs out of the box, because PSBTs seem partially signed Bitcoin transactions. Just for people in the live stream that might not be familiar, they're typically used in they're becoming an emerging standard for multi-signature
Mm-hmm.
transactions, right? Because you have the
Mm-hmm.
ability to, like, if you have multiple counterparties in a transaction, it gives you the ability for some set of those counterparties to sign the transaction and basically pass it around to those different entities and like do different types of do a transaction in that
Yep.
way. So it defines that it's a new
Yep.
standard for that. Is that right? Or
Yeah, that's true. It's basically a very nice way of like making a single transaction in a collaborative process. Like you have like multiple people are associated with it and they have to put their signatures, but they need to know all the transaction data. So PSBT is basically all the metadata that a signer needs in order to sign a transaction. So this is a very good way of like a very easy way of doing multi-signatures. This is a very easy way of like transferring the transaction data from the wallet software to the hardware wallet, right? The hardware wallet needs to know all the data in order to sign it. So all the metadata that a transaction need or a signer needs rather in order to sign a transaction are given inside a PSBT. So BDK also works on PSBT. So when we say like we have done putting data inside our transaction template, we will say the transaction builder to finish it, and that will basically spit out a finalized PSBT. Sorry,
got you,
not a finalized PSBT, an unsigned PSBT. So now
got
we
you.
have to sign this PSBT.
Okay, okay, I got you. Um, and so I can bring some more stuff in here. So you said we need to sign it. So we have our wallet.sign passing in our PSBT, and we've defined some sign options. So
Yes.
assume
So the
height,
signing
is that
option
block height?
the signing option is basically, if you go to the signing option definition, we are not using any signing option here. We are just using the default signing option. But the signing option is basically an extra feature in BDK that we can use in order to more fine grain our signing process, right? So we can say like whether we have some trusted witness UTXOs or not, whether we say like we should wait for certain block heights in order to make this transaction confirmed or not, and all these kind of options.
Like
So
we can set
you can,
time lock, and the time lock can be defined as like I'm assuming like a Unix timestamp or block height.
block height.
Yeah.
Yeah, yeah. So at the time of signing, it will also check whether the UTXO is matured or not, in like whether the UTXO is allowed to be spent or not. So if
Okay.
the UTXO is still inside the time log, the signing function will fail. It will say like we cannot sign it because it's not matured yet.
Got you. Okay. Makes sense. Okay, and then we pass in those sign-in options. and then we extract the now signed PSBT.
Yes, in a proper Bitcoin transaction format, and then we tell the wallet to broadcast this transaction. So
Yeah, got
for
you.
broadcasting, the wallet will also go for the RPC backend. So it will tell the RPC backend, just like we use the code send raw transaction thing. Then it will also call a similar RPC process, and it will use the Bitcoin core to broadcast this transaction in the network.
Got you. Okay, got you. So
Right.
that's cool. And then confirm transaction by, okay, and then we need to generate some more blocks again, basically.
Yes.
Because
And then we sync again to update our balance.
Okay. And then, all right, so this is pretty much coming to an end, and then we basically want to print the balance to a terminal. So if I get this right, our BDK, our core wallet balance should be deducted by 5 BTC. I think that is. I can't make out those zeros at the minute, but I think it's 5 BTC. So core wallet should have 45 BTC because I think we had 50 when we did the 101 mined 100 blocks because of the Coinbase transactions, and then our BDK wallet should have 5 Bitcoin, I think, but
yes,
I'm not 100% sure. But let's see anyway.
Let's see. Let's try.
Let's see. Yeah, let's try. Cargo run. Okay, what's going on in the chat? Anything in the chat? No, we still got 4 people who managed to stay with us to the end. I'm pretty proud of that. Thanks for staying on. Okay, let's see. It's doing things. Oh, it was 150 BT. Okay, yeah. So okay, that worked, right? Because yeah, I said we were gonna have 5 BTC. I guess this is accounting for like transaction fees.
The reason it's 144 is like we have also made 2 more generate to address call, right? So that creates 50 more BTC for the core wallet. So the core wallet had 150 BTC minus 5 around 144.99, and the BDK wallet got 5.
Yeah. Okay. All right. Well, that was pretty successful, wasn't it? I think.
Yep, it went better than I hoped.
Yeah, that's really cool. So yeah, that was pretty straightforward as well. And the I've not done much Rust, but like it's very like I feel like it's quite smooth. Like the typing seems pretty on point as well. But like we mentioned earlier, we are trying to support different languages as well. So the flow is pretty much going to be the same, but like you just get to write it in your language of choice. So cool. Well, thanks for that, Raj. We're kind of just over the 2-hour mark, which is a good effort from us, I think, and a good effort from the people who are still on the live. Is there any like questions? We can maybe hang around for 5 minutes just to see if anyone's got any questions. I know there's not many of us in the chat at the minute, but we can hang about. If not, we'll end the stream, and we'll hope to try and do this. I'm hoping to try and do it on a weekly. We really want to try and get people up and running with some of the latest developer libraries that are coming up. Okay, we have a question. Does BDK integrate with LDK? That's a good question. Raji, do you want to take that one, or should I talk a bit on that? Or
yeah, so basically the process of integrating BTK and LDK is ongoing as far as I know, and John Cantrell is working on it. So it's a work in progress pretty much, but there is a very much plan to integrate BTK and LDK together and create this super wallet that can do all the Bitcoin and Lightning stuff like a pro. So yeah, it's gonna be coming, but
yeah,
yeah,
I guess I should
gonna be a lot of
maybe
work.
say what Lightning Dev Kit is as well. We are going to be doing some tutorials on LDK as well, many more on BDK and any other Bitcoin-based libraries and topics as well. So we're definitely going to touch on that in the future. So stay tuned for that. That is currently being worked on by John Cantrell 97 and have some PRs being reviewed on in BDK to help make it happen. Yeah, thanks for that. So yeah, the two libraries are coming together quite nicely. So awesome. All right. Well, I have to thank you for this, Raj. This was amazing and went smoother than I thought. And thank you for your patience with my rusty Rust skills. Yeah, though we hope to do this again like every week. Hopefully, hopefully the people's time is permitting to this kind of thing. And yeah, we'll catch you again soon.
Yep, it was
Peace.
fun.